He didn't give us any in class.
Huh. We're probably only going to meet twice more before your final. So
Yes.
now would be a great time to start reviewing for your final, because I tell you what always happens. People come to me that last week and they have a semester's worth of material to review, and we end up with a half-hour session and you just can't do it. So the solution to that is let's start reviewing for your final now. It's a little harder because it means you have to search through and figure out what topics to review, um, as opposed,
I know I need help with factoring.
okay, I can help you with factoring. I can make some up. Okay, let's
Okay.
absolutely make sure that you know how to factor.
Alright.
That will cost you dearly if you don't.
Alright.
Go through it step by step, as the way I'd like to see it. If you're really good at it, I don't care how you do it. You could use whatever technique you want. But if you're not good at it, unfortunately, you're going to have to use my technique, which might not be exactly what
I'm not.
they taught you. They might have taught you something where you draw a diamond like that, and you put numbers here and here and here and here. And it's, to me, very
Yeah, I never.
complicated and very confusing. My technique is far easier, particularly on these easy ones here.
Yeah.
There's really only 3 steps here. What's step 1?
Um, do we need to like break it up?
Break the x's up. That's
Yeah.
always step 1. It's not always x and x, but in this case it's x and x, because x times x is going to equal x squared.
Yeah.
Now, what's step 2? And this is the one everybody wants to do different. So I'm assuming they didn't teach this step 2 to you in class. But trust me, with
Uh,
quadratics like this is what you want for step 2.
um, I. What
Figure
were you
out,
gonna say for step two?
figure out both signs.
Oh, okay.
What do both signs have to be?
Um, like addition signs, right?
Plus, plus.
Positive.
Now,
Yeah.
what we really know, in other words, we're examining that plus right there, okay? The only way we can produce a plus 10 is if the signs are the same. They don't have to be plus plus, they could be minus minus, but the very first thing we know is that they have to be the same.
Yeah.
And then to see what they should be, look to your middle term. Well, that's a plus. That tells us they have to be plus plus.
All
So
right.
that's step 2. We've split up the x's as step 1. We've figured out both signs. Now step 3 is what?
Um.
Factor
Yeah.
of,
Factor your. Yeah.
factors of 10 that add, because of that plus sign, to the number 7.
Okay.
What are they?
That add to the number 7. Does it have to be two numbers, or can it be more
It
than
has to
two?
be 2 numbers that are factors of 10. In other words, 2 numbers that multiply to 10.
Um. 2 and 5.
There you go. And it doesn't matter which goes where. It's as simple as that. It's a simple 3-step procedure.
Okay.
Okay? Now, I'll give you one slightly harder.
Okay.
It's slightly harder because of that negative sign right there. That's going to add a 4th step.
Okay.
First 3 steps, pretty much the same.
All right.
What's first step?
Look at the x's.
So x and x. What's second step?
Figure out your signs.
What are they?
Minus minus.
No, if I had minus minus, this would not be a minus 10. It would be a plus. In other words, I'm examining that negative sign right there. That tells me
Alright.
both signs have to be opposite. The only way you can produce a negative 10 is if you're multiplying two signs and you have an opposite sign. Notice that whatever number goes there and whatever number goes there, my last step when I multiply these two things back together again is to multiply that number by that number, and it's going to be negative. So that's what factoring is reverse multiplication.
Yeah, okay.
Once you learn how to multiply by FOIL, or every term by every term, that's what you're working on. I know that when I multiply these two terms together, and it doesn't matter what my numbers are, it could be 20 and 30, I know that the constant is going to have a negative sign in front of it, because your constant comes from the last step of FOIL, which is to multiply plus 20 times minus 30. So
Yeah.
that's the key thing when you're factoring, is to look at the sign on the constant. That tells you a lot of stuff. So we figured out that the signs have to be opposite. And in this case, it doesn't matter if I put the plus here and the minus there or reverse. There's no difference as long as it's 1x times 1x. Now, the third step. Same kind of logic. Factors of 10 that subtract, not add, but subtract to the number 3.
1 and 2.
Factors
Wait, no,
of
no, no,
10.
no.
Have to multiply
Factor
to 10.
10. Oh, man, alright.
Here's the way to factor. Start with that.
5 and 2?
If you can cut this in half, and if you can, then you got to double that. Now I can't cut that in half anymore, so I'm done. That's all the factors I have. So again, these are the two factors that I'm looking for. But now I have to decide,
Yeah.
does the 5 go with the plus sign or does the 5 go with the minus sign? And the rule is the bigger number, 5, goes with the sign of the middle term, which is negative. So the 5 goes right there.
Yeah.
Which leaves the 2 to go there. And we're done. So this had a fourth step. In other words, in the previous problem, it was only 3 steps, because once we found factors of 10 that added to 7, it didn't matter where the 5 went and where the 2 went. You could have switched them and it would have been the same. But as soon as we have a negative sign in front of the constant, we know we're going to have opposite signs, which once we find our factors that subtract to that middle coefficient, then we have to figure out which one goes with which sign. And like I said, always put the larger factor with the sign of the middle term.
Okay.
Make up another one. Now, so far as all we've been doing is factoring expressions. Let's turn this one into an equation. And you'll see why factoring is so important. In other words, if I want to solve this equation for x, not easy to do as long as it's in the form of a quadratic. But if I can factor it and get it so that it's the product of two things, well, now I can solve it easily, because I'll set whatever that thing is equal to 0 and solve it, and then I'll set that equal to 0 and solve it. And I'll have two answers for x. Okay? So that's why factoring is so important. So I'll do step 1 for you. What's step 2?
Okay. Figuring out your signs.
What are they?
Plus and minus.
Okay. Step 3?
Factoring your negative 20.
I find that it helps if I can get students to verbalize it. Because once you verbalize it once, you'll never verbalize it differently any other time. Factors of 20 that subtract to the coefficient of the middle term. What's the coefficient of the middle term?
The coefficient of the middle term is the coefficient is the
Is 1.
x, right?
Is 1. It's
X.
whatever the number is in front of the middle term. We don't write it because it's 1, but it, could easily be 3 or something. But in this case, that's why I made this problem up, because a lot of people don't see that the middle term's coefficient is 1. So we're looking for factors of 20 that subtract to the number 1. Okay? Examine factors of 20. Well, again, I'm going to cut this in half as my first step, always. Means doubling that. Now I can do it again. I can cut 10 in half. Doubling that. Can't cut it in half anymore. That's all of my factors of 20. Which set of factors subtract to the number 1?
5 and 4.
5 goes where?
It goes in the first one, the first column.
Yeah. And the 4 goes there. Now that we're getting a little bit harder ones, we want to do the next step, was to just always to check the middle term. Make sure you've done it right. Okay? I don't need to check this term. I know that's going to be x squared. I can see that x times x is x squared. I don't need to check this term. Minus 20. I can see that plus 5 times minus 4 is minus 20. But the middle term is created from the O and the I of FOIL, multiplying the insides together and the outsides together. That's plus 5x. This is minus 4x. Add those two together, you get plus 1x. That's the proper middle term. We did it correctly.
Wait, what happened?
Can you hear me?
Yeah.
Okay. Did you lose audio for a moment, or the screen? Or? Nick, are you still there?
Yeah.
Okay. Where are we at here? Can you still see my screen?
Yes.
Okay. So this step, which I call double smiley faces, becomes a critical part of the factoring process when they get harder. In other words, the moment I put a number in front of that first term, like a 2, now all of a sudden it's a higher degree of order of difficulty to factor. And we'll talk about that if we have time in the next 10 minutes, but we'll do at least one. And you will see that this double smiley face becomes an integral part of the process. It's not just a checking process. In other words, for these problems that I've given you today, I only needed this to demonstrate how we would check our middle term. But now I'm going to give you one. Hold on a moment. Hold on a second. Let me see what that's equal to. That is 2x squared minus 8x plus 5x, so that's minus 3x in the middle minus 20. So let's do this one. Oh, incidentally, on that other one, the solution to the equation is what? If my factors are x plus 5 times x minus 4, what are my values of x?
1.
No? Remember what the other side of the equation is.
Oh.
The only way two entities can multiply together and be equal to 0 is if at least one of them is 0. The only possible way.
Oh,
So set each
yeah.
one equal to 0 and solve. If you set this one equal to 0, what's x equal to? If x plus
X
5
is equal to
equals
0.
0, what's x equal to?
Yeah. 0.
Solve this equation that I just checkmarked for x. Subtract 5?
X equals 0, right?
No. If x plus 5 equals 0, what does x equal?
-5.
Yeah. In other words, you got to subtract 5 from both sides, right? So there's one
Mm-hmm.
solution. This solution, I'm going to set x minus 4 equal to 0. Solve that for x.
4.
Okay, there's your two solutions to that equation.
Mm-hmm.
Okay, we got it by factoring. Now, we got just a short amount of time, but I think I can explain when they get a little harder, like this. And harder basically means anything that doesn't start with x squared. Okay?
Yeah.
Okay, now these have kind of a different set of rules. First step, still the same. Break up the first x squared. How do I break it up? However I break it up, they have to multiply to 2x squared.
Yeah, so it'd be 1x, well, yeah, 1x on both sides.
No?
Sides.
If I
Or
had
just x.
x times x, then that's going to multiply to 1x squared.
Oh, wait, what the heck? Oh, wait, what?
I need a 2x right there.
Yeah, but then the other side would have to be 2x, right?
No? No, they
Really?
don't have to be the same. Because all my goal is to split up that 2x squared. And remember, multiplication is happening here, not addition.
Oh, yeah.
In other words, once I come up with my two linear factors, when I multiply them back together again, the first term I get is that term right there. And 2x times x is 2x squared. Okay? So the first step is to still break the x's up.
Mm-hmm.
Second step. What's the other second step?
Uh, it is to find our signs.
Okay, what are they going to be here?
They're both minus.
No.
So
If they were both minus, this would be a plus.
they're going to turn into plus.
No, they're not both minus. What's another possibility? They're both opposite.
Okay.
One has to be plus, one has to be minus. Remember the last step of FOIL. You multiply this term right here by this term to produce that term.
Yeah.
Well, that term is minus 20. The only way I can produce a minus number is if I'm multiplying a plus times a minus. So the signs have to be opposite. Now, because this is a 2 and this is a 1, plus minus is not necessarily going to be the same as minus plus.
Mm-hmm.
This gets more complicated. So I have to allow for minus plus also. And this is the way I do it. I write it like this. Okay? Now I don't really know what to do. Let me list all the factors of 20. In other words, I no longer have any simple rules. I can't say factors of 20 that subtract to the number 3. I can't say factors of 20 that subtract or add to the number 3. That rule goes out the window when you have anything other than x or x. In other words, as long as one of these x's has a number higher than 1 in front of it, then this becomes a trial and error process. Well, I tell it, in other words, is all you're going to do is try these combinations until you produce this middle term. Well, I suggest everybody always try the two factors that are closest together. 5 is closer to 4 than 10 is to 2, or 20 is to 1, right?
Yeah.
So my first attempt here, and this is without a doubt a trial and error process. My first attempt is going to be a 5 here and a 4 here, just randomly.
Mm-hmm.
And I'm going to just keep trying combinations until I produce a minus 3x in the middle. Well, the way I figure out what I'm producing in the middle is with these double smiley faces. Only I'm not doing it to check my answer. I'm doing it to figure out my answer. Well, in the way I've factored it right now, what goes in the top smiley face?
The top smiley face would be plus minus 5, correct?
Plus 5x. Remember what I'm
Yeah.
doing. I'm multiplying the two inside terms together. And there's a plus with the 5 and that x, so that's plus 5x. What's the outside?
Minus 4x.
Minus 4 times 2x. What's that?
Oh, minus 4 times 2x equals minus 8x.
Add those two together.
You get negative 3x.
Ah, that's my middle term. I got it right on my first guess. So the answer is 2x plus 5 times x minus 4. However,
Okay.
let me back up a moment here because there's a lot to learn by the failures. Let's say I wasn't so lucky and I started out by this one. I put the 5
Yeah.
there and the 4 there. What's the middle term? Or what's the top smiley face?
Would it be minus 5x?
What's the bottom smiley face?
Um, plus 8x.
Add them together and you get the right number but the wrong sign.
Yeah.
That tells me that the right answer merely needs me to move the 5 up and the 4 up.
Mm-hmm.
So, and that's very interesting because what if I would have started with the 4 on the right side over here and the 5 there? Now notice the inside is plus 4x. The outside is minus 10x. Add those two together, I don't get the right number. So there would be no point in me trying moving the 4 down to the negative and moving the 5 down to the positive, is all I'm going to get is a plus 6x. That's all that happens when you move those numbers to the other sign. So what that tells me is that I can't have 4 on the left and 5 on the right. I need it the reverse. Because I didn't even produce the correct number here.
Yeah.
So, and if no combination of 5 on the left and 4 on the right works, well, I go back to the drawing board and I try 10 and 2.
Okay.
No combination works there, I try 20 and 1. If no combination works there, I resort to the quadratic formula to solve it.
Yeah.
But if they have indicated that it's factorable, it's always going to be easier to solve by factoring it than it is by the quadratic formula.
Mm-hmm.
Just it is. The quadratic gives most people a headache even saying the word. But
Yeah.
notice this technique. It was strictly trial and error. I had no reason to start with a 5 here and a 4 there. I had 4 possible choices, right? In other words, if I'm going to go with these two factors, and like I said, always start your trial and error process using the factors that are closest together, because that's usually the answer. And I got 4 different places I can try them. Well, if I don't get the first one right, I have to try a different one, but I've eliminated 2 of the possibilities. So now I only have 1 more possibility to try. So I really don't have to try 4 different things. I only have to try 2 different things. Because like I said,
Yeah.
if I'd have tried putting the 4 over here and the 5 over there, I'm producing either a plus 6x or a minus 6x, depending on whether the 5 is next to the plus sign or the minus sign. So these, what I call higher level quadratics, are significantly more difficult to factor. But you'll
Mm-hmm.
notice that a necessary step of the factoring was this figuring out that middle term. Again, I don't need to make sure of that term. I know that term is correct. I know how to split up 2x squared. And
Yeah.
this term is only created by the f of FOIL. And this term is only created by the L of FOIL. It's the middle term that is created by the inside and the outside. And that's what the
Yeah.
little smiley faces do, is multiply the inside terms together, the outside terms together, and adds them together to make sure you come up with the correct middle term. But notice that I cannot say that factors of 20 that subtract the 3. They don't. 5 and 4 subtract the 1. They add to 9. So that nice little rule that you can use on those first level quadratics, you can't use on higher degree quadratics. And
Yeah.
it's after 5, so I gotta run. Nick, I will talk to you next time, and I will talk to your sister in 30 minutes.
All right. Sounds good.
Bye-bye. Should I
Bye.
just